Good evening to everyone. I'm Pushpashri, faculty of Bhat and Bhat Tutorials. I'll be handling mathematics for you. So, well, my dear kids, in the last session, we have discussed the square and square root and the cube and cube root chapter. And in today's session, let us know about the rational numbers. So, this is the new chapter for you that I'll be starting with in today's session. So, first, we'll get to know what are the meaning of rational number. So when we come to the meaning of rational number, a number which can be written in the form of p by q, where p and q are the integers and the q is not equal to 0. We are going to call that as a rational number. That means that where we are going to write the number in the form of p by q, like 2 by 3, 6 by 7, 7 by 8. So here we are going to write the numbers in the form of p by q, where the value of q, that means the denominator, will not be equal to 0. Say for example, if I write 2 by 3, here 3 is not equal to 0, where 3 is the number which carries a higher value than a 0. For example, you can see here minus 2 by 3, comma 6 by 7 are the examples for rational numbers, where you are going to write the numbers in the form of p by q. And are the rational numbers. So here they had given the example minus 2 by 3, 6 by 7. These are, we are going to call it as a rational number. Since the numbers 0, minus 2, 4 can be written in the form of p by q, they are also called as rational numbers. Even the numbers like 0, minus 2, 4, we can write this in the form of p by q. Okay, so that's the reason even we can call that as a rational number. So with this we can understand that the number which we are going to write in the form of p by q, where the q, the value of the denominator, will not be equal to 0, so we are going to call that as a rational number. Okay students, now I'll just move on to the next one. You can see here the properties of rational number. Then what are the properties of rational number? So we'll just see to that one by one. So the first property, that is closure property. What is closure property? So closure property is a kind of property which can be used in the properties of rational number, where anything that you're going to add, or you're going to subtract, or you're going to multiply, or you're going to do divide. So whatever the answer that you're going to get will be one or the another, we will be closed with a whole numbers. Okay, so when you see the closure properties with a whole number, under that the first one type is whole number. In that we get a different kind of operations like addition, subtraction, multiplication and division. So along with that we have some of the numbers as well as the remarks. We'll just see to that. So when I come to addition, 0 plus 5 will be equal to 5, a whole number. So 4 plus 7 is equal to what then? So whether it is a whole number or it is not a whole number. Students, as you all know, whole number is a number including with 0 all the natural numbers included with 0, we are going to call that as a whole number. Generally, we are going to tell a plus b is a whole number for any of the two numbers, that is a and b. So whole numbers are closed under addition. Say for example, if you add any two numbers, whatever the result that you're going to get will be of whole number itself. And when I come to the subtraction under the whole numbers, you can observe here 5 minus 7, which is equal to minus 2. Why we have got minus 2 here? Because 5 is the least number, 7 is the greatest number. So with any of the least number, if you subtract any of the greatest number, your answer will be of negative 1, which is not a whole number. And the whole numbers are not closed under subtraction. So under subtraction, these whole numbers cannot be considered. Okay. And next, the third operation is multiplication. You can see here 0 into 3 is equal to 0, a whole number, where 0 is also whole number. So then 3 into 7 is what? Whether it is a whole number or not. So in generally we can tell that a and b are the two whole numbers, and the product of a and b are a into b is equal to ab. And whole numbers are closed under multiplication. Okay. And when I come to division, 5 divided by 8, we are going to write that as 5 by 8, which is not a whole number because it's in the type of fraction. So whole numbers are not closed under division. So this is about your closure property under a whole number. Next, we will see the properties of rational number. The first property, the second subtype, that is integers. So in the closure property, right now we learned about the whole numbers, and now we are learning about the integers. So in integers also we have four operations, that is addition, subtraction, multiplication, and division. So when I come to the numbers in addition, minus 6 plus 5, which is equal to minus 1, because plus into minus is minus, so 6 minus 5, it is 1. In before the greatest number there is a sign of subtraction, so here in before 1 I am putting minus 1. It is an integer, is minus 7 plus 5 into plus 5 is an integer. Whether this number is an integer or not, we have to find it out. Say for example, see students, one of the important thing, any number which is written inside the bracket, bracket is the symbol of multiplication. Always remember that bracket is the symbol for multiplication. See here, plus into minus is minus, minus into minus it is plus, so then 7 plus 5 is what? And then in the same way 8 plus 5, whether it is an integer or not. Say for example, in generally a plus b is an integer, we have two integers with us now, a as well as b, and integers will be closed under the addition. And then when I come to the subtraction, see here, 7 minus 5, which is equal to 2, an integer, it is an integer. Whether is 5 minus 7 is an integer, you don't know. And then minus 6 minus 8, which is equal to minus 14, whether it is an integer or not, even we have to find out that. In the same way, minus 6 minus into minus of 8, see here, minus into minus will become plus, so plus into minus is minus. 6 minus 8, it is 2, whether it is an integer or not, we have to find it. So we can tell that as by this, integers are closed under subtraction. Under subtraction, integers are closed. Okay. And when I come to multiplication, 5 into 8, it is 40, and it is an integer. In the same way, minus 5 into 8, whether it is an integer what or not, we have to find it out. But here you can see here, minus 5 into minus 8, which is equal to plus 40, because minus is minus into minus, it is plus, so plus 40 you have got, and it is an integer, usually in the form general form. If we have two integers, say for example a and b, we can write that in the form of a into b, where that is an integer. So we can tell that integers are closed under multiplication. And last but not the least, that is division. So the division here you can see 5 divided by 8, which is equal to 5 divided by 8, which is not an integer, because here it is, we are going to write that in form of fractions, and integers are not closed under division under the rational numbers, that is under the closure property. And now we are going to discuss about the second property, that is cumulative property. So cumulative property under the whole numbers. So cumulative property is a property so which will be like a LHS will be equal to RHS always. Okay. So here also we have four operation. First one is addition. Second operation is subtraction. Third operation is multiplication. And the last but not least, the fourth operation, that is division. So when I go with one by one operations, the first operation is addition. Here you can see the numbers, that is 0 plus 7, which is equal to 7 plus 0. However you do, 0 plus 7 is also 7, and 7 plus 0 is also 7. In the same way, 2 plus 3 is 5. In the same way, if I do 3 plus 2, then also you will get 5. So addition is cumulative. So for any two whole numbers, say for example a and b, we can write it as a plus b, which is equal to b plus a. In the same way, when I come under subtraction, it is also in the same way, but instead of addition sign, you will put subtraction sign. Say for example 0 minus 7, which is equal to 7 minus 0. So answer that you're gonna get is always the same. In the same way, 2 into 3 is 6, and 3 into 2 is 6, vice versa if you do. So subtraction is not cumulative built. But what happens here? Multiplication is cumulative, but subtraction is not cumulative. Why? 0 minus 7, you will get some answer. And 7 minus 0, you will get some other answer. So, subtraction is not cumulative under the rational number. But when I move on to division, what happens? Division is also not cumulative. Why, ma'am? 4 divided by 2, you will get one answer. 2 divided by 4 is one more answer. So, division is not cumulative under the whole number. And the next is integers. Under integers also we have 4 operation: addition, subtraction, multiplication and division. So under addition, if I take 5 plus 3 plus 3, which is equal to plus 3 plus 5. So here you are going to get the answer. 5 plus 3, it is 8, and 3 plus 5, it is also 8. That means addition is cumulative. But when I come to subtraction, 5 minus into minus, minus into minus, it is plus. So 5 plus 3, it is 8, but here minus into minus, it is plus. And then in before the smallest number, there is in before the greatest number, there is a sign of subtraction, so it will become minus 8. So subtraction is not cumulative under the integers. And when I come to multiplication, LHS will be equal to RHS as usual. 5 into 3, which is equal to 3 into 5. 5 3s are 50, 3 5s are 50, where multiplication is cumulative. But when I come to division, 5 divided by 3, you will get one answer. 3 divided by 5, you will get one more answer. So division is not cumulative under this integers. Then we'll see the last property, that is associative property. Under associative property, you have again the whole numbers. Again, you have 4 operation, that is addition, subtraction, multiplication and division. So under addition, the numbers are like this. So for example, the numbers will be 7 plus 2 plus 5, which is equal to 7 plus 2 plus 5. So whatever you LHS will be always equal to RHS. So we'll tell addition is associative. But when I come to subtraction, a bit different will be, that is 7 minus 2 minus 5, which is equal to 7 minus 2 into 5. Okay, so sorry, minus 5. Here subtraction will not be associative, because sometimes on LHS side you will get addition, and sometimes on your RHS side you will get subtraction. So we'll tell that subtraction is not associative. But when I come to multiplication, what happens? See here, 7 into 2 into 5, which is equal to 7 into 2 into 5. So vice versa, if you do, say for example, 2 into 2 is 4, or 4 or 2, again if you do 2 into 2, it will be 4. Say for example, if you take any other number, 3 2s are 6, 2 3s are 6. So multiplication is associative, I can tell. But when I come to division, division is not associative. Sometimes in division you will get decimal numbers, sometimes you will get an exact answer. So we'll tell that division is not an associative. The second part is integers. Under integers also you have 4 operation: addition, subtraction, multiplication and division. So under addition, if you see, minus 2 plus inside the square bracket, 3 plus n2 minus 4 and close the bracket and again the square bracket. So if you add the numbers, you will get this one answer, and that answer will be equal to your another answer that you are going to get it. So we can tell that addition is associative. And how we can tell that? A plus B plus C will be equal to A plus B plus C. You can see here, A plus B is just there inside the bracket on the right hand side, but on the left hand side, B plus C is there inside the bracket. But if we add both the things, the answer that we are going to get is A